Okay folks, so today we're going to have a complex number intro, because we'll need it for the next thing we're moving on to. Okay, so complex number intro. Okay, we will go into much further detail with complex numbers, but I just need to show you the first thing. Okay, so let's consider this example. Okay, consider the quadratic equation and I'm going to give you z squared minus 6z plus 25 equals 0. Okay, so if we were to find the roots of that, we would use the quadratic formula. Okay, so using the quadratic formula from National 5, then a would be 1, b would be negative 6, and c would equal 25. Okay, so if I go and check the discriminant first of all, which is always the first step we do, we check the discriminant first, so that's b squared minus 4ac. Then that would give me negative 6 all squared, take away 4 times 1 times 25. Okay, what that gives me as an answer is negative 64. Okay, so back at National 5, that would have been known as no real roots, and you would have stopped. Okay, because you wouldn't be able to find the roots. Whereas at Advanced Higher, we are able to find the roots. The difference is our roots are now going to have to be imaginary. So let's go further into the quadratic formula and let's put negative 64 into the square root. Okay, so if I put into my quadratic formula, so z would equal negative b plus or minus square root b squared minus 4ac all over 2a. If I substitute the numbers in again, so that would be giving me 6 plus or minus negative 64 in the square root, and that's why that was a problem before, and 2 times 1 is 2 there. So I will get that far. Okay, and again, originally we would have been told to stop because we couldn't work that out. So let's do something here. So now let's think of the negative 64 as 64 times negative 1. Okay, so we can split surds up. Now the square root of 64 is 8. So that would be 8 times the square root of negative 1. Okay, so now let's suppose we can make this imaginary. So suppose that every time we have the square root of negative 1, we'll call that I. Okay, lowercase I. So what that would mean is that the square root of negative 64 would actually be known as 8i. Okay, so if I put that into the quadratic formula again, it would be 6 plus or minus the square root of, sorry, not the square root, square root of negative 64 it was, over 2. That would equal 6 plus or minus 8i, that's what the square root of negative 64 became, over 2, which becomes 3 plus or minus 4i. Okay, which means that both roots would be 3 plus 4i and 3 minus 4i. Okay, just take the positive and the negative version of both there. Okay, So the important thing to know is about this rule here. That we can let the square root of -1 become that imaginary number for us to work I. Okay? There's a few things you just need to note about it as well. So note, okay, so the first note is that I is known as an imaginary number. Okay? And maybe highlight that as well, okay? So that's important. But I is known as an imaginary number. And in general, a complex number is of the form x plus iy, sorry, yi. X plus yi, where x and y are real numbers. Okay, so in our case above, x would have been 3 and y would have been 4, or -4, depending on which version of root we're talking about. Okay, so that's the first thing to note. And the second thing to note is that I equals the square root of -1, so that being the case, I squared is always -1. Okay, so if you square I, that means you square the square root, so therefore you end up with -1. Okay, so that will allow us this year, when we get onto complex numbers more so, we will look at squaring and taking squares out of numbers, okay, which means that we can do that with the letter I. Okay, that's the first thing I'm going to show you, which will help us towards one of the types of differential equations we look at after this video. Okay.